Hello everyone, welcome to Incredible Study. Today in this lecture we know about magnetism, and under this magnetism topic we discuss four topics. First one, magnetic flux, second one, electromagnetic induction, third one, magnetic effect, and fourth one, transformer. So without getting delay, let's start our lecture.
Welcome to Incredible Study.
Here we need to know about our topic, that is magnetism, before going to these subtopics. So let's know about magnetism. What is magnetism? Magnetism is the property of magnet with which it attracts magnetic body. This is called magnetism. Okay, and now we go to our next topic, that is these all subtopics. Gradually we finish this all topics. First topic is magnetic flux. What is magnetic flux? Now here we know suppose this is a magnet. Suppose this is a magnet. This is its north pole and here is south pole. Then what happens? The lines of magnetic forces externally goes from north to south, in this direction, like this. It goes here in this, like this it goes. And in this process what happens, when magnetic lines of force externally goes from north to south, and internally it transfer from south pole to north pole internally. Therefore these magnetic lines, when changes takes place in these magnetic lines, the current is induced. Here what is magnetic flux we are going to study. So this number of lines, what happens when these numbers of lines falls on a surface, okay, per surface having the unit area. Suppose here is a surface, that is this surface, and when these lines of forces fall on this, number of lines falls on this surface, unit surface, is called magnetic flux. What is magnetic flux? The number of lines of magnetic lines of force falls on the surface having unit area, is called magnetic flux. This is very simple topic. Okay, when suppose you consider this, suppose this marker is line of force, then, and this is also, okay, here when this line of force, and this is a surface, here is a surface, when these lines of force fall on this, here two lines of forces fall on this surface, two lines of forces, okay, then the magnetic flux of is 2, only 2 for this. In this case only 2 is there, and but here you can see in this case there is 4. This is called magnetic flux. Okay, and here when magnetic flux is passing, it always falls perpendicular on the surface. This is surface, then it always falls perpendicular. Example, here this is a magnetic lines, then, and when it falls on the surface, it falls perpendicularly, making 90 degree. So we can define magnetic flux as the number of magnetic lines of force that falls perpendicularly on a surface having unit area. Okay, let's write here. What is magnetic flux? Magnetic flux. Here the number of magnetic lines of force fall perpendicularly on the surface having unit area. This is called magnetic flux. Similarly, we move to our next topic, that is electromagnetic induction. What is electromagnetic induction? And before going to this topic, you need to know about what is electromagnet. What is electromagnet? So we define electromagnet as a temporary magnet which is formed by passing electric current to a conductor. Then this is called electromagnet. The magnet which is formed by passing electric current is called electromagnet. Okay. Now we move to our next topic, that is electromagnetic induction. What is electromagnetic induction? So we know we have concept about magnetic lines of force. Okay. Here this is a magnet having north pole and south pole. Suppose this is a coil. Having coil. This is a coil and it is magnet, bar magnet, strong bar magnet. And then what happens? This line, suppose there is a line of force. Lines of force. It goes like this. Now we know about electromagnetic induction. This is figure. Okay. This is a bar magnet and it is coil. What happens when coil is brought near to this magnet? Then the magnetic flux get changed. Magnetic flux get changed. Okay. Suppose this is a coil. When this is brought this side in this contact, then the magnetic flux get changed. Okay. This coil affects the magnetic flux. Okay. And in this time what happens? There is one galvanometer. Okay. Galvanometer. Here this is a galvanometer. It measures the direction of current. What happens when this coil is brought near to this north pole of the magnet? Then the galvanometer goes right side. It increases. And when it is at rest, when it is kept at rest, then the galvanometer shows at center. It shows at middle. When this coil is moved away from this magnet, then it goes in the opposite direction. It shows here. It shows three directions. What happens when this coil is brought near to this magnet? Then its direction goes right side, means increases. And when this coil is kept at rest, then this galvanometer shows at 0. And when this coil is moved away from this magnet, then it shows opposite direction. Galvanometer goes in negative direction. It means it decreases. Then it shows the direction of this current. Okay. And what happens when this coil is brought near to this magnet? It cuts the magnetic flux. Causes magnetic lines of forces. This cause changes in magnetic flux, and when magnetic flux change, the EMF is induced. And as a result, current is induced in this coil. Therefore, this phenomenon is called electromagnetic induction. What happens once again you listen? Suppose this is a coil. When this coil is at rest, then galvanometer shows here 0. And when this coil is moved toward this magnet, then it changes the magnetic flux here of this magnet. So it shows here this side. It shows increasing. And when this coil is moved away from the magnet, then it goes in negative direction. This phenomenon causes, it means electric current is induced in this coil due to this phenomenon. And when the coil is at rest, then no any electric current is going to be induced in it. Therefore, we can say electromagnetic induction as when magnetic flux gets changes and EMF is induced, this phenomenon is called electromagnetic induction. The result of induced EMF causes induced current. It means current is produced in this coil. Therefore, this is called electromagnetic induction all together. Now, here we discuss this. Here, whenever the magnetic flux changes, an EMF is induced in the circuit, which is called induced EMF. Here, EMF means electromotive force. This phenomenon is called electromagnetic induction. Okay, and the resulting current by electromagnetic induction is called induced current. What I told here, when coil is moved, then the magnetic flux get changed. And due to this magnetic flux, EMF is induced in this circuit. Your circuit should be here. When this closed coil, it should be closed coil. Okay, so EMF is induced in this circuit, and this phenomenon is called electromagnetic induction. And due to this electromagnetic induction, current starts flowing in this coil, and this current is called induced EMF. What is induced EMF? Okay, and one thing we have observed here in this picture or phenomenon, that when the coil is in motion, then only deflection in the galvanometer takes place. It means it goes to either it increases or decreases. Only deflection takes place when the coil and the magnet is in relative motion. So we can say when the magnetic flux only get changes when the coil and the magnet is in relative motion, Okay, therefore we have also finished electromagnetic induction in this way. Now we go to our next topic, that is magnetic effect. What is magnetic effect? Now we go to our next topic, that is magnetic effect. What is magnetic effect? So whenever, suppose this is a coil, whenever the electricity is passed in this coil, what happens? Electric field is generated. Magnetic field is generated in around this. Magnetic field is generated around this coil when the electricity is passed here. Here, this is a conductor, and when electricity is passed in this conductor, then the magnetic field is generated around it. This effect is called magnetic effect. So we can say what happens when current is passed to the conductor, magnetic field is generated, or it produces magnetic field around it. This effect is called magnetic effect. Let me write here. What is magnetic effect? Okay, when current is passed through a conductor, it produces magnetic field around it. This effect is called magnetic effect. Okay, now we move to our next topic, that is transformer. What is transformer? And we discuss everything about transformer. Here we discuss transformer. What is transformer? We all know the transmission of electricity with the same potential difference is very difficult. Okay, transmission of electricity over a long distance with the same potential difference is very difficult, and potential difference, when the current is passed to the long distance, potential difference decreases. Okay, and we all know when potential difference decreases, it is very difficult to get electricity. And we all know that electricity is at the power station, electricity is generated is very low, having low potential difference, so it must be stepped up so that electricity transferred to the long distance. And similarly, we don't need high voltage AC current in our home or for domestic purpose, so it must be stepped down to use. Okay, therefore the decrease and increase of this electric voltage is done by a device called transformer. Okay, thus the transformer is a device which converts high volt AC voltage to low AC voltage. Okay, and vice versa. Transformer is a device that changes the voltage either from high AC voltage to low AC voltage or low AC voltage to high AC voltage. Okay, now transformer, there are two types of transformer. Here we define transformer. Here, transformer is a device which is used to convert high voltage AC to low voltage AC and vice versa. It is a device. Okay, and there are two types of transformer: step up transformer and step down transformer. Types of transformer, we know transformer. Types of transformer. There are two types of transformer. First one is step up transformer. Step up transformer and step down transformer. Step down transformer. You may have question, what is step up transformer and what is step down transformer? So no need to worry, I am going to explain these two topics. When the electricity is generated at the power station, then there is low potential difference. Okay, and to increase this potential difference, step up transformer is used. What do you know from here? It means step up transformer converts low AC voltage to high AC voltage, low to high. It is the type of transformer that converts low AC voltage to high AC voltage. Low AC voltage to high AC voltage. I don't think I need to tell you this one, okay, because just inverse. It is the type of transformer which converts high AC voltage to low AC voltage. It converts high AC voltage to low AC voltage. Low AC voltage. And there are something that you need to know under these two topics. And we know transformer is like this. This is a transformer. Suppose here is a coil. Here is a coil. And here is also coil. What happens in a step up transformer? This coil is called primary coil and this is called secondary coil. Primary coil and secondary coil. In a step up transformer, the number of primary coil is low. Yes, and the number of secondary coil is greater. So that when the electricity is passed here, secondary coil is greater. Therefore, more amount of electricity is converted here, is induced. Therefore, primary coil in the step up transformer is less than the secondary coil, and for this step down transformer just inverse. What happens? The number of primary coil is more than the secondary coil. Number of primary coil is greater than the secondary coil. When the high amount of electricity is passed with the help of primary coil, then the electricity get decreased due to the presence of low number of coil. Okay, we have now understood about step up transformer and step down transformer. Now we discuss what is primary coil, secondary coil and core. First one, primary coil. What is primary coil? So here we draw a figure of transformer. What is primary coil? It is the coil. It is the coil in which AC voltage is supplied, AC current is supplied. Coil through which AC current or voltage, you can say, is supplied. It means it is connected with source of electricity. It is connected with the source of electric current. Okay, now under this we know what is primary turning. What is primary turning? It means the number of winding of this coil is called primary turning. The number of winding in primary coil. In primary coil is called primary turning. Primary turns, we can say. Primary turn. And the voltage which is supplied to the primary coil is called primary voltage. Voltage supplied to the primary coil is called primary voltage. Primary voltage. Here always AC voltage is transferred. Here it's supplied. So here we know AC voltage is supplied to the primary coil is called primary voltage. The voltage which is supplied here, the AC voltage which is supplied to the primary coil is called primary voltage. In primary coil, for the step up transformer, the number of this primary turns is less than the number of secondary turns. Secondary turns. Similarly, for secondary coil, we write here secondary coil. What is secondary coil? So it is the coil through which stepped up or stepped down. Stepped down current is induced. It is the coil through which stepped up or stepped down current is induced. Here from this secondary coil, stepped up or either stepped up or step down current is induced from this coil, and the number of windings in the secondary coil, here primary coil just change here, secondary coil is called secondary turns, and AC voltage which is obtained, not supplied, which is obtained from the secondary coil is called secondary voltage, and the number of here primary turns is represented by N1. Here this voltage is represented by V1, this, and the number of turns that is secondary turn is represented by N2, and secondary voltage is represented by V2. Okay, we can see we use this all in formula. Now we move to next topic, that is working principle of this transformer. What is the working principle of this transformer? So when current is passed here, when voltage is transferred to this primary coil, then the magnetic lines of force changes, its magnetic field also changes, and due to this change in magnetic field, magnetic flux gets changed, and when magnetic flux gets changed, then EMF is induced. It means, and it transferred to this, slowly, and here transfer. Okay, when current is passed in this primary coil, then magnetic field of this coil, lines of magnetic force get changes, and in this way magnetic flux also get changes, and this change in magnetic flux causes the production of current in this secondary coil, and we can get here current from this secondary coil. So we can say this coil is based on the mutual induction, principle of mutual induction, and principle of mutual induction states when electricity is passed and EMF is induced in a coil, due to which an EMF is induced in the secondary coil. Okay, here I will write now, here principle of, we write principle. Okay, principle of mutual induction, mutual induction. What happens? It states an EMF is induced in a coil by passing alternating current in neighboring coil. Here this is the principle. This principle states an EMF is induced in a coil by passing alternating current in neighboring coil. It means what? Here EMF is induced in the secondary coil by passing alternating current in primary coil. Okay, therefore in this way we have finished our topic, that is transformer, and there is the one formula for this, okay, in under transformer topic, and using which you are asked numericals. Using that formula you can solve all the numericals related to this transformer. Here is formula: N2 by N1 is equal to V2 by V1, and I have told what is N1, N2, V1 and V2. Here N2 means number of secondary turns, here, and N1 means number of primary turns. What is primary turns? Here V2 means secondary voltage and V1 means primary voltage. Okay, now we discuss one topic under transformer. One topic is left, okay, that is core. now we discuss about core. What is core? Here core means iron core, you can say iron core for this transformer. What is core? We all know, you may have seen that when you see transformer, then transformer is made by this several E like this, many E slot, or this is of iron, many E are overlapped one after another. These all E are overlapped one another, and this overlapping, you can say U shape or E shape, either E shape or U shape, you can say. So we can define here the E-shaped iron, U-shaped or E-shaped. Iron to fix primary coil and secondary coil is called this iron core. This is called iron core. Here E-shaped or U-shaped, in which here it is to fix the primary coil. Here primary coil is fixed and here secondary coil is fixed. So this is called, what is core? This is called core, and it is made up of soft iron bar, soft iron. Okay, here this I have told several E-shaped or U-shaped iron bar, iron core is, or soft iron core is laminated one after another, means is overlapped one after another. Suppose this is E, then it is lapped here, this like this, several are overlapped one another. So to prevent the conducting, here they are polished, this E or U are polished with shellac or varnish, shellac here or varnish. Here this lamination of this core is when this polishing is taking place. No, when we join this E-shaped or U-shaped iron by polishing on it, this process is called lamination of core, and lamination of core is done with the use of shellac and varnish. Shellac or varnish, this is a kind of paste or something, substance like that. Shellac or varnish is used for the lamination of core. And why lamination of core is done? You may ask question that why the lamination of core is done. So here is the answer. Lamination of core is done to prevent the transferring of heat, or to prevent it from excessive heat and energy loss, to prevent the transformer from excessive heat and energy loss. Therefore it is laminated with varnish or shellac. In this way, no any topic is left under this transformer topic. And in this way we have completed our lecture. First one we have discussed about magnetic flux, second one electromagnetic induction, third one magnetic effect, and fourth one detail about transformer. Therefore this lecture ends here, and if you find this video helpful, then like this video and subscribe to our channel. Thank you for today.